Section 1.2, Objective 6, Convert between fractions and decimals. Part 2, Convert a fraction to a decimal. Okay, convert a fraction to a decimal. To convert a fraction to a decimal, divide the numerator of the fraction by the denominator of the fraction until the remainder is 0 or the remainder repeats. Let's do an example. Let's convert 7 over 25 to a decimal. So 7 over 25 means the same thing as 7 divided by 25. So as long as we remember that, we'll be able to do this problem. I'm going to rewrite it this way. I'm going to write the 25 on the outside. I'm going to write the 7 on the inside. We ask ourselves, how many times does 25 go into 7? It doesn't go into 7. It goes into 7 0 times, right? It doesn't fit. So we're going to add a decimal right here, and we're going to write that decimal directly above where it's at. Notice I'm trying to be very neat and organized, and I'm trying to align everything vertically, neatly. I'm going to add a 0 right here after the decimal. How many times does 25 go into 70? It goes into 72 times. 2 times 25 is 50, so we're going to subtract. 0 take away from 0 is just going to give me a 0. And if I take away 5 from 7, I'm going to get a 2. Okay. And this is denominator is not 0, and I need to keep on going to see if it actually repeats. So I'm going to add another 0. I'm going to bring this 0 down here and put it right here next to that 0 and ask myself, how many times does 25 go into 200? It goes into 208 times. Notice how I'm writing the 8 directly above the 0 that I just recently added here. And now I'm going to go 8 times 25 is 200. I'm going to subtract 200 from 200, and that's going to give me a 0. Because I now have a remainder of 0 here, I know that this is a terminating decimal, that this decimal ends. So when you have a remainder of 0, you will end up with a terminating decimal. In other words, this decimal up here, this decimal ends. Because there are some decimals that are not terminating. They do not end. Okay, so this is our final answer. So 7 over 25 is equal to 0.28, or another way to say this is, remember, the 8 is in the hundredths, so we could say 28 hundredths. So 7 parts out of 25 parts is the same as 28 parts out of 100 parts. It's another way to think about it. All right, let's do one more example here. Let's convert 7/9 to a decimal. Once again, I'm going to set it up the same way I set up the last problem. So I know that 7 divided by 9 is the same thing here, written this way, 7 divided by 9. And I'm going to write the 9 on the outside. I'm going to write the 7 on the inside. And 9 goes into 7 0 times. So I'm going to put a decimal. I'm going to bring that decimal directly above. I'm going to add a 0 right here. And then I'm going to ask myself, how many times does 9 go into 70? It goes into 77 times. 7 times 9 is 63. So I'm going to subtract. And I get 7. Notice that I had originally started with a 7 up here. This 7 right here, notice that I had a 7 up here. So it looks like this is a repeating decimal, but just to be on the safe side, let's do a few more here. Let's bring down this 0. We're going to end up here with 70. We're going to ask ourselves, how many times 9 goes into 70? It goes into 77 times. 7 times 9 is 63. And once again here, I end up with a 7, just like I had before. So I think at this point we can see here that this is going to continue to repeat. So we have a choice here with the way we want to write this. We can write this as 7/9 is equal to 0.7 with an over bar, right? And that's going to mean that the 7 is just going to continue to repeat. So we can use this notation. Or there's another type of notation we can actually use. 7/9, and we could write it this way. We could write a couple of the 7s here so you can see what the pattern is. And then we write 3 dots. And those 3 dots, that's called an ellipses. And it just means that the pattern repeats. So it's the same, it works the same way. Both notations are fine. Okay, I'm going to do just one more example where we have not just one number repeating, but sometimes 2 or 3 numbers might repeat, so you can just see what that's going to look like. So I'm just going to do one more example right here. Let's convert 7/11 to a decimal. So if we have 7/11, remember 7/11, it still means 7 divided by 11. We're going to set this up. We're going to write the 11 on the outside. We're going to write the 7 on the inside. 11 goes into 7 0 times. We'll put a decimal, line it up directly above, add a 0. 11 goes into 76 times. 6 times 11 is going to give me 66. And if I subtract, I'm going to get 10 minus 6, and that's going to be 4. I'm going to bring down another 0. 11 goes into 40 3 times. 3 times 11 is 33. We're going to subtract. It's going to give me a 7. So right here, you might notice we got a 7, and we actually started off with a 7 right there. But let's just add a few more digits here, see what happens. We're going to end up here with 70. 11 goes into 70 6 times. 6 times 11 is 66. We subtract. It's going to give me 4. Bring down the 0. And then 11 goes into 40 3 times. And that's going to give me 3 times 11 is 33. And that's going to give me, once again, 7. So right here, I think it's pretty clear that we can see that there's a pattern repeating here. 63, 63, right? Or 63, 63. Or you could also see that pattern over here where we saw the 7, 7, 7, and we also got a remainder here of, I think it was right here, 4, 4. It's like a block of numbers repeating. So we can write this, once again, a couple different ways. We could write it as 0.63 here, and we're going to put the repeating bar over the 6, 3, because that's the block of numbers that is going to be repeating. 6, 3, 6, 3, 6, 3, right? This is going to continue. We could also put the ellipses on it the way I did up here to show that that pattern continues. Okay, that's it.